Question 8. Okay, we get a function here. This is the function given, where k is a positive integer. And we need to show that the equation of fx equals 0 has no real roots. So let's write down the equation. Sorry, I don't have to show that it has no real roots. Given that it has no real roots, I have to show that the greatest possible value for k is 5. So if it has no real roots, it means that the discriminant is negative. So the term k squared minus 4 times half times 13 is negative. Then I get under the square root, when I try to solve this equation, a negative expression, and therefore there is no real roots. So here I get k squared minus 2 and 2 cancel down, minus 26 is less than 0. So I plot this quadratic equation with a variable k. So this looks, in order to solve this inequality here, I plot it. It's a parabola, and it has here 2 roots, which comes from the solution of this equation. So it has 2 roots, the negative and the positive square root of 26, and the root of 25 is 5, so the root of 26 is 5 point something. I don't even bother to write it down. Now I have here 1, the positive value, and here I have the negative value, and I want this term to be under the curve. It should be less than 0. So the solution for this inequality is when k is between those two values. And since I know that this one is 5 point something, it means that k have to be less than 5 point something. Now I have to keep in mind that k is an integer, a positive integer. So if it has to be smaller than 5 point something, it can be maximally 5. And this is the answer to part A. Moving on to part B. So first, for part B and C, we consider k to be 5. Okay, and then we have to write down the equation for the excess of symmetry of f. So first I write down f when k equals 5. So it's half x squared plus 5x plus 13. The excess of symmetry is always in, we have to take the coefficient of x and then put it in the numerator, and in the denominator I have to put 2 times the coefficient of x squared. This is a known formula for the excess of symmetry of a quadratic equation. Then I get here -5. This is the answer for B1. Now in B2 we have to show, or we have to determine the coordinates of the minimum points of F. So the excess of symmetry, this line x equals -5, it goes right through the minimum point of F. Yeah, so if I have F here, this is the minimum point, and the line of symmetry for F is right here. X equals -5. So of course the minimum point is -5 point something, and now I want to calculate this something, so I simply plug in -5. I substitute -5 to the function, and here I have the function, so I get half -5 squared plus 5 times -5 plus 13. So this is 25, and this is -25, and this is 12.5. So I get here -12.5 plus 13, it's a 1f. So minimum point of F is at -5. Yeah. And this is the answer for B2. Now moving on to part C. So in part C, so they show here F, and they give us another line which is L, and is the normal to the graph of F at the point x equals -3. And at first we need to show that this normal line to F at x equals -3 has an equation that is written here. So I will write down F again. And now I want to write down the equation for L. L is normal to F. So I want to write the equation of this line. Let's start with the slope of this line. So I can calculate the slope of the tangent line, because the slope of the tangent line, I will call it or I don't have to give it a name, it's simply the derivative. By definition, the derivative of a function gives us the slope of the tangent line at a specific point. So if I will take the first derivative, which is 2 times fx plus 5, and then I will put it at the point -3, then I get that the slope, the derivative, is 2. So this is the slope of the tangent. But I also know that the slope of two lines which are perpendicular to one another, the slope of the normal of L times the slope of the tangent, which is 2, equals -1. This is known for two perpendicular lines. And therefore, the slope of the normal L is -half. Now I also know that L, the normal line, goes through the point -3, and I can also find the y coordinate of this point. Sorry. Five times -3 plus 13. So I get here 9 divided by 2 is 4.5, plus 13 is 17.5, and minus 15 is 2.5. So I know that L goes through the point -3, 2.5. And now I have the slope of the line, and I also have a point which it goes through, so I can calculate the equation of L. I'm using the formula where m is the slope and x1, y1 is a point which the line goes through. So I get here y minus 2.5 equals -f times and if I simplify it, I will get -f, and here I get minus 1.5, so it's +1. And this is exactly what we needed to show in part C. Now part D. So I'm going to sketch it, the area that we need to calculate. We add the quadratic term. And here was the tangent line L. Here we have the point -3. And we have here the area which is limited, it is closed by the quadratic graph from above, the line L from beneath, and the y-axis here on the right side. So this area A is the integral. I just take the function from above minus the function from beneath. So the function from above is f x squared plus 5x plus 13, and the function from beneath is the equation of L, which I just calculated in part C and was minus fx plus 1, and I need to do the x of all of this term, and of course I have to put the boundaries. So I calculate the integral here. It begins at -3, and what closes the area from the right hand side is the y-axis, which has x value of 0. Yeah, so let me sum it up. I add from above this function minus this function. This is what I put inside the integral, and I take the two boundaries from the left to be -3 and from the right to be 0. And now I just have to calculate this integral, and this will give the requested area. So let's begin. First, I'm going to simplify the term under the integral. So I have half x squared plus 5.5 x, which are 11 over 2 x, and 14. Sorry, and 12. Plus 13 minus 1. So let's integrate. Here I get f x to the power of 3 divided by 3 plus 11 over 2 times x squared divided by 2 plus 12x. And sorry, here I already integrated, so I don't need to put the integral sign. It was already integrated. But I still have to plug in the boundaries, -3 and 0. I start by putting the upper boundary, which is 0. So if I'm going to put it here, here, and here, it's all going to be 0. And then I put a minus, and now I have to plug in the lower boundary. So let's do that. So I have -3 to the power of 3 divided by 6 plus 11 over 4 times -3 to the power of 2 plus 12 times -3. So -3 to the power of 3 is 27. -27 divided by 6. Here I get -3 square is 9. So I get 99 over 4. And here I get -36. So I'm going to simplify further without a calculator. So here I have 24 divided by 6 is 4, and I left with 3 over 6, which is 4.5. Here I get 4 times 25 is 100, so it's 24. And then it reached 96, then I left with 3/4 minus 36, and here I add a negative sign, and everything else was also with the negative signs before. So I get here the final answer. 24 minus 4 is 20, and 3/3 minus f is a quarter, and minus 36. So I get here negative and another minus outside. This is 15 and 3/4. This is the answer to part D.